Welcome back. We're in Projectiles Exemplar number 3. You should have done 1 and 2 already and checked that against my solution. So I'm going to go quicker and, well, I'll go as in depth as the other ones, but I'll be going quicker through this. So as I'm assuming you already have all that other information. So you can watch that little clip there. And let's go ahead and draw this water slide here. So we got a 165 foot long water slide. Man, that is a big water slide. It goes down, something like that. They take off at 30 miles an hour. I'm just going to go ahead and label that right now. Now, V naught is going at some angle there at 13.4 meters per second. We'll use the SI units, standard international units. That is an angle of 30 degrees off the ground there, so I should draw that vector maybe a little bit bigger and nicer and neater. And then I can draw the component vectors a little bit nicer and neater as well. So now my component going horizontal with the ground and how fast it's going straight upwards there. Those things are perpendicular with one another. And then this is the angle between the vector and the ground, the horizontal. And that's 30 degrees. So we have 30, 60, 90 triangle. That's nice. I'm immediately going to go ahead and label this side as 13.4 times the sine of that 30 degrees and 13.4 times the cosine of 30 degrees. Take off from a position 4 meters above their landing position. Got it. So I'm going to go ahead and I'm going to draw this. Something like this. Yes. And then let me grab a different color here so this can stand out, because now this height right here, down to that delta y there, that is 4 meters. And then they go and they land somewhere. So they take off there, and maybe I'll keep doing it in red. So they kind of go something like this, and they land down here. I'm going to call the down here my height, my vertical height of 0. Probably, I think most people probably would. I even put that down here, that y is equal to 0 right there. So that means that, and I'll even label that here, that y naught is 4 meters. It's a positive 4 meters there. Yeah, okay, cool. So y naught is 4 meters. Let's see, did I get everything there? I got the original velocity. I got the water slide is 165 feet long. My guess is we're not using that, but I'll go ahead and put that down because I would put everything down. Now, 165 meters long where? It's this curved thing there. So I'm immediately going like, how am I even drawing that? Is it like the straight portion here? I don't know. Is it the straight portion and the curved portion? Maybe. If it's the straight portion and the curved portion, are you measuring like along this curved device here? And so I'm not even going to label it. I'm just going to put a question mark. If I need to come back to that, maybe I'll come back to that, because I don't even know how to label that on there. And I'll make some guesses if I need to come back to that. Ignoring air resistance, as we always do, how far away from the bottom of the ramp should the slider land? And so we're looking from, they took off right there, and they landed over there. So we're looking for that delta x from there to there. Boom, boom. And that's equal to a big old question mark there. And I usually do that so that I make sure I'm on the straight and narrow and I remember what I'm doing here. Okay. So you know that the x dimension and the y dimension are two separate things. Usually there's more work to be done in the y dimension, so I give that a little bit bigger space. Here's my x. Actually, I'm not going to write dimension anymore. I usually write just x. Maybe get a nice little header. Just y, give it a nice little header. We're assuming that the Cartesian coordinate plane is what we're using here, as we're pretty used to doing. Delta x is 1/2 at squared plus v naught t. I go and put in some values that I know. The velocity in the x direction, I know what that is. Hey, what's the acceleration in the x direction? Oh, that's a big fat 0. Because we go, we should put that on there. Hey, I know gravity is pulling this thing down. We can list that. Anything that's a push or a pull is some sort of force. And the force of gravity is the only thing we've actually looked at for pushes and pulls. We'll look at all of them in detail in the next unit. Hey, and that causes some acceleration due to gravity. We call that lowercase g, and that is 9.8 meters per second squared. In this case, it's pointed directly downwards, as it normally is. So I go ahead and put the negative on there. because I know that's going to be a negative value. Now remember that that's in the vertical dimension there, and x in the x dimension, I don't have any acceleration because nothing's pushing it or pulling it left or right there. So then that simplifies that x dimension equation right there. Delta x is now just my v naught. I'm going to go, well, I would leave it as v naught. V naught, and I'll maybe even put subscript x there just to remind myself I'm still in the x dimension, multiplied by some time. I don't know the time. And I do know the v naught x. V naught x is 13.4 cosine 30 degrees. So I'm going to go ahead and put that in. So it's ready to go if and when I figure out that time value there. You've done these other ones and going, hey, I probably can figure out the time value. This has happened before where we've come into a roadblock here and it's easily overcome by just going to the vertical dimension. Let's see if we can figure out anything else in the vertical dimension there. I'm going to start with the same equation here. It seems to be quite useful. And I know some things. I'm also thinking to myself, I know some things about delta y. I know where it starts, the vertical height, and where it ends. That can be very useful. And so let's go ahead and let's see if we can figure out what we know here and what we don't know. Let me just go through the numbers here. Hey, delta y, we know that that's the ending bit minus the beginning bit. The ending bit is 0, the beginning bit is 4, so we actually know that that's going to be equal to negative 4 meters. It's dropping down 4 meters, right? You're ending 4 meters lower than where you began. That's what the negative 4 is saying. Okay, so we know that value. Careful, it's not 4, it's negative 4. I know the acceleration, we already said that, that's negative 9.8. Because it's in the vertical dimension. And we know this guy here, we just labeled it as 13.4 sine of 30 degrees. My sine looks like a 5 over there. Man, oh, because the dot for the I melded with the S and made it look more like a 5, that's why. Sorry about that. So then I look at this equation, I go, wait a second, I only have one variable, t. I can solve this. Cool, so let's go put things in. Negative 4 is equal to 1/2 negative 9.8 t squared plus 13.4 sine 30 degrees. And I look at that and I go, that's a solvable, oh, times t, sorry. Oh, watch out. Almost missed that. And I go, look, I only have t as my only variable. I only have one variable. And so one equation, one variable, I can solve that. And I look at that and go, that's a quadratic equation, so I'm going to move the 4 over to the other side as I know to do to be able to solve this. 1/2 times 9.8 is negative 4.9. You're hopefully getting used to that now. You'll be doing that a lot throughout the year, as there's always that 1/2 there hanging out there. And then plus my 4 meters to the other side. So now I just have a standard quadratic equation. I go and pick up my calculator, and you solve that however you want. I don't care how you solve that, as long as you are solving it, and you know how to use the tools that are in front of you. And I'll always say, hey, you can use a calculator to solve something like that. Now, I have a calculator here, so I am actually going to go through and show you. Oh, can I make this thing rotated? I don't know. Settings. Let's see if I can. I'm sorry. I was hoping that this would just automatically. Well, the settings menu automatically rotates. Faceplate, largest screen. I don't see it. Okay. Thanks for an ad, Meyer. Looks like it can't automatically rotate it, but I think you'll be able to get it anyways. Did you know that a quadratic, the formula, you don't have to type it in every time. This calculator does it for you. Did you know that? Hit that math button on the left-hand side underneath alpha. Scroll down. Go to solver. Now, depending on what version, the 84, the 83, you could have, it might look a little bit different. This is the harder one to understand, so it's good that I have this one anyways. Notice, put in any equation, and this thing will solve it. Quadratic, quartic, so on and so forth. It will solve it. That's really nice. Notice it's got 0 equals everything else, so I'm just going to put in everything else because I already have my equation equal to 0. Now I could put in t if I wanted to, but if you look right next to alpha, it has the xt theta n button, and so that's the variable depending on what space you're graphing in. You probably have it set up to graph in the Cartesian coordinate plane, so that's the x button. So it's just easy to push that there. Plus I'm going off memory here, 13.4 sine of 30 degrees. Oh gosh, the sine didn't go in there. Sine of 30 degrees. And I make sure that my calculator is in degrees there, which I'm quite certain it is because I just had done a problem. I got to multiply all that by x still. my variable, whatever variable, in that case t, and then I add 4 to that side of there as well. So now I have the equation set equal to 0, put in, and I press enter, and it doesn't do it for me. Check that out. It just gives me some value. That's not the answer. Careful, it's not the answer. It just took me to the next screen. I can press up and go to that previous screen. I could even just press down, and it takes me to this next screen there. Notice it didn't solve it. So I got to tell it to solve. Look at the enter button real quick, and then look at the other colored words there. You'll notice that there's a button that says solve. The enter button also serves as the solve button. Maybe that'll solve this for us. It's like somebody wrote this and programmed it to be able to be used by a reasonable person there, and you're a reasonable person. So go ahead and hit alpha enter, and that will then tell the calculator to solve that thing. And so now it solves it, and boom, it gives me an answer. And there's one of my answers. Now check that out. I have a degree 2 polynomial. And you expect how many answers from a degree 2 polynomial? And you should say, well, 2. At least 2. Now sometimes there's multiples, as you know, in math class. And sometimes there's extraneous ones. But I should always get 2 solutions at least. And so, yeah, you do get 2 solutions. But it only gave you 1. What gives? Here's what's going on. Remember when you go to graph something and then you wanted to find a point on the graph and it asks you tediously to guess? And you're like, why is it asking me to guess? Well, it's asking you to guess because there's multiple solutions, or there might be multiple solutions, and it doesn't know which one you want until you guess something that's relatively close, and it'll give you the answer that's closest to that value. That's what happened right here. And you'd say, I didn't put in a guess. Yes, you did. You just didn't know it. You had some number stored as x beforehand. In this case, I'm going to put in 2. That's your guess. And if I go and hit alpha enter, it will give me the answer that's closest to whatever number was in there beforehand, in this case 2, and it gives me 1.8. However, there's another answer here, and my guess is, and I don't even remember from last year, my guess is it's something probably in the negative region, so I'm going to put in negative 10, I don't know. And if there's an answer closer to negative 10, then it'll give me that. And lo and behold, there is. Oh, there's my other answer. So I have 2 answers here. And if that doesn't work, you just keep guessing larger, more extreme values there, and it'll give you the other one. It's pretty easy since we have a degree 2 polynomial, so there's, just 2 there. So we have one answer is negative 0.449. Now, in our case, that doesn't seem like it's probably going to be right because it's a negative time and we're not going backwards in time here. So that's going to be an extraneous solution there. It doesn't make sense for this situation. So I'm going to put in my other guess there. And again, my other guess, let me just do that. My other guess doesn't have to be 2. It could be 99. It could be anything, but that's closer. But that this other answer, the 1.8, is going to be closer to that 99 or that 2. As were my 2 guesses there. Now, what's also really nice is you go, oh, I got more than even 9 digits there. Do I have to write down all of these things? And I go, well, kind of, but no, you don't. Because check this out. That's stored as what letter? Take a guess. Yeah, that's stored as X. So if I go second mode, which is my quit button, I get back to the home screen there. And now if I put in X, if I just type in X, and then press enter, it'll tell me the value of X. Oh yeah, it's stored in the calculator already as X. Well, that's convenient. Great. So now you can use that, and you don't have to graph and find the right window for your graph and monkeying around with that. It takes too long. So we just got, what was it, 1.8. Oh, what was the second digit there? Come on, Mr. Wishway. 1.82, because we got to round that 6, or that 1, and then we got to use the 6 to go up there. So we got 1.82 is the time there to get down to the ground, and that is the total time that we just found there because my ending position that I used there was 0, so that's what it refers to. And now that's the time, so I can just plug in that time and I can go do that. Since I have the calculator there already, and I really wish that this did rotate. I'm sorry that it didn't. Hopefully I can fix that at one point, but anyway, you probably still see this anyways. So now I need to do 13 point, oh gosh. I didn't actually check to make sure I put in that equation right. I was just doing it off of memory. I guess I'll go back and do that now. 13.4 cosine of 30. And then I need to multiply that by the time. Well, notice that the time is already programmed in as x, so I just put that in as x, press enter, boom, there I am, 21.08. That was way more efficient than me trying to write down numbers and put them back in. 20. 20.08. Is that what I just said? Nah, dang it, now I gotta look back. I was like thinking about making this video and everything instead of holding numbers in my head. 21.08. Oh, good thing I looked back. 21.08. Man. And then 13.4. Well, I got that right the second time when I put in the 13.4, and I'm going to go check. I go to math because I want to get back to that solver, and I can just hit up to go to the bottom of the list there, and solver is the one on the bottom. And I see that I put in 13.4. I can press up to get back to the equation screen there, and I put in 13.4. So it looks like I did it right. It's always good to double check yourself. I make mistakes on these problems, even though I've done them thousands of times. Actually, that would be very interesting if I knew how many times I've done all these problems. And not these particular problems, but just projectile problems in general. Let's see, what else? Did I get everything? I ignored air resistance. How far away from the bottom of the ramp should the slider land? We got that. Oh, is that all I was asking? That's it. Oh, that wasn't too bad. All right, cool. That's it. Have a beautiful day. See ya. Bye.